Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 6 to 10 of the Algebra 1 Common Core New York Regents exam for January 2016. All right, let's take a look at number 6. It reads, Michael borrows money from his uncle, who is charging him simple interest using the formula I equals PRT. To figure out what the interest rate R is, Michael rearranges the formula to find R. His new formula is R equals. Now, what is this this problem asking us to do? It says in his new formula, R equals. When you have R equals, what they're asking us to do is basically solve for R. Okay, or get R isolated so you have R equals something. That's what this problem is asking us to do. Now, one thing you want to recall is that when you're solving an equation, when you're solving a formula for a variable, like you have this formula right here, interest equals principal times rate times time. When you're solving a formula for a variable, it is the same thing as solving an equation for an unknown. The same process is involved, okay? So in this case, we're getting R isolated. To accomplish that, we have to undo these two variables that are associated with R. So the question is, what is the relationship between P and R and T and R? It is a multiplicative relationship. PRT, you have a multiplication relationship there. Okay, if you have letters next to each other, that's a way of writing multiplication. Now, in order to get R isolated, we have to undo P times R and T times R using the inverse. So what is the inverse of multiplication? The inverse of multiplication is division, okay? So to get rid of P times R, to get rid of P, we have to divide by P. And to get rid of this T right here, we'll also have to divide by T, okay? But in order to preserve equality, just like we're solving an equation, whatever you do to the right side, you have to do exactly the same thing to the left side. Now notice what happens on the right side. The P's divide out. P goes here 1, P goes here 1. T goes here 1, T goes here 1. And you're left with R. R is isolated. Okay, that's the goal. So we have R equals, remember what the question asked, R equals interest, I, divided by principal times time. As you can see, our correct answer is option number 3. All right, let's take a look at number 7. It reads, which equation is equivalent to y minus 34 equals x times the quantity x minus 12? Now you see two sets of options here. The first one you have a factored situation, and in the second one, 3 and 4, you have completed squares. Now, thinking about completing the square, one thing you want to recall is if you want to complete the square of an expression in ax squared plus bx plus c standard format, you simply add b over 2 square to the incomplete square component of that expression, okay? Another thing you want to note is that when you're completing the square, you have to add something, add a term to a particular part of the function to create a perfect square trinomial. Now, whatever you add, you have to subtract the same term from the same side of the equation, okay? So let's say you're completing the square here in this example. To complete this square, of course, you add b over 2 square. In order to preserve equality of this function, what you added here, you have to subtract from the same side, b over 2 square, okay? When you're dealing with equations, it's kind of different, but when you're dealing with functions, you're dealing with the same side, so whatever you add, you have to subtract. So in essence, these two cancel each other out if this function is expanded completely. All right, so let's keep those points in mind. Now let's go take a look at the function. We have y minus 34 equals x times x minus 12. So we have to get y isolated first and simplify this on quantity. So let's distribute x to x and negative 12. So that gives us y minus 34 equals x squared minus 12x. Okay, if you look at the options we have here, you notice that y is isolated. So to accomplish that, we add 34 to both sides of our equation. That yields y equals x squared minus 12x plus 34. Okay, so the question is this a factored state of this, or is this the completed square form of this equation right here? The easiest process to do is factoring. So I'm going to attempt to factor this and see if I get 1 or 2. Okay, so let's try factoring. I'm going to use the X game. That's a nice little method to factor quadratic trinomials. AC goes on top. A is 1, so we have 1 times 34. AC goes on top. And B, negative 12, goes on the bottom. So the question is, what two numbers multiply to give you 34 and add to give you 12? All right, so let's make our product of pairs that yield 34. I know that 1 times 34 gives me 34, but if I combine these two, I either get 35 or 33. That's not 12, that doesn't work. 2 times 17. If I add these two, I get 19. If I subtract, I get 15. I can get 12. No other number goes into 34 because 17 is prime, okay? So guess what? This expression is prime. It cannot be factored. So we can simply eliminate options 1 and 2. We have to complete the square, all right? So how do we complete the square? Well, take a look at this information here. Remember, just add b over 2 squared to the incomplete part. So first thing we're going to do, let's rewrite the function, is create an incomplete square. So I'm going to do that by grouping the first two, okay? The first two terms. So this is my incomplete square. My goal now is to use these two terms to create a perfect square trinomial. Okay, so I'm going to write y equals x squared minus 12x plus a term that makes this a perfect square trinomial, a term that completes this square. Okay, plus 34. So remember what I asked us to note earlier, whatever you add to one side of the function, you subtract from the same side. So in essence, they cancel each other out and you haven't changed anything, okay? All right, so what term completes the square here? You simply use b over 2 squared. B is 12, so b is 12. What do we do with that? Divided by 2. 12 over 2 is 6, and you square it. 36. Now, this is a number that makes this incomplete square a perfect square trinomial. So insert a 36 here, and then a 36 here also, so that they, in essence, cancel out upon expansion to result in this original function that we have. Okay, now we're going to go ahead and factor this perfect square trinomial. Now, there are different ways you can factor this. I'm going to show you a neat little trick, a shortcut that you can always use to factor perfect square trinomials, okay? So all you do is you take the square root of the first and the last term and bring down the middle sign. All right, so the factored form of this perfect square trinomial is x square root of x squared minus the middle sign. The square root of 36 is 6, quantity square, okay? And then what is positive 34 minus 36? Subtract, keep the sign of the bigger, minus 2. Okay, so this is the vertex form of this quadratic function that we have right here. All right, so let's take a look at it. Our answer is option number 4. All right, let's take a look at question number 8. It reads, the equation A equals 1300 times 1.02 raised to the 7th power is being used to calculate the amount of money in a savings account. What does 1.02 represent in this equation? Now, one thing you want to remember concerning the growth formula, let me write down what the growth formula is. One thing you want to remember, so the growth formula is, formula is y equals a times 1 plus r to the t. So one thing you want to remember is that the r in the growth formula is percent growth in decimal form. So the percentage was converted to decimal format before it's inserted into this formula. Okay, so that's something to keep in mind. Another thing to note is that this is a growth formula because of the plus. Okay, this plus you have right here is a growth formula. If it were 1 minus r, then you will have a decay situation. All right. So with these points in mind, let's go ahead and solve the problem. So let's see what this 1.02 means in the context of this growth equation. Okay, so let's go ahead and rewrite this formula. We have A equals 1300 times 1.02 to the 7th power. Okay, if you look at the growth formula right here, it's expressed as 1 plus r. Okay, so let's apply that pattern to this equation. We're going to have 1300 times 1 plus what gives you 1.02. 1 plus point, or let's write it as 0.02 gives you 1.02, and that's being raised to the 7th power. Okay, by separating 1 and the decimal component, you can easily identify what the growth rate r is. Okay, because the formula is a times 1 plus r to the t. Okay, let me reorient this equation. So we have the formula again is a times 1 plus r to the t. As you can clearly see, this number that has been added to 1.02 is the growth rate in what form? In decimal form. Please keep that in mind. Is the growth rate in decimal form. Okay, so let's go ahead and write that down. The growth rate R is equal to 0.02 in decimal form. Okay, but if you look at the options we have here, the options are all in percent form. So what must we do? We must convert this growth rate from decimal to percent. To convert from decimal to percent, you simply multiply by 100 or move the decimal point 2 places to the right. Okay, so R, which is equal to 0.02, is equal to, if you move the decimal point 2 places to the right or multiply by 100, you end up with 2%. So we have 2% growth as the significance of this 1.02 in the growth equation provided. Answer is option number 4. All right, let's take a look at question number 9. It says the zeros of the function f of x equals 2x squared minus 4x minus 6r. Now, one tip is that if you are asked to find the zeros of a function, all you simply do is set the function equal to 0 and solve. Okay, those are the two parts of finding the zeros of a quadratic function. Now, one caution you want to keep in mind is that, let's say x plus 2 is a factor of some function. The related zero is -2, not 2. You have to set it equal to 0 and solve before you determine what the zeros are. Okay, don't just factor and try to determine the zeros from the factored states. That's playing it risky. Okay, now let's go ahead and find the zeros here. So as indicated here, we're just going to set f of x to 0 and solve. All right, so what is f of x? F of x is 2x squared minus 4x minus 6 equals 0. And solve. So we're solving a quadratic equation. Now, you always want to try and simplify it as much as possible to make the factorization process easier. So is there a greatest common factor I can extract from the left side of this equation? The answer is yes. 2 is a greatest common factor that can be extracted. Okay, so I'll factor out a 2. What does it mean to factor out? If you're factoring out, it's as though you're dividing everything by that factor and putting that number on the outside. So if I divide 2x squared by 2, I'm left with x squared. If I factor out 2 from 4x or divide it by 2, I'm left with 2x. And then when you factor out 2 from 6, it's as though you're dividing 6 by 2, and you're left with 3. Okay, so that is equal to 0. Now I can divide both sides by my common factor, which is 2. Remember, you can only divide numbers, don't divide out variables, okay? What you do if you divide variables is that you are eliminating zeros, and you cannot do that. Only divide numbers. Okay, so if I divide both sides by 2, what I'm doing in essence is reducing the equation, all right? I end up with x squared minus 2x minus 3 equals 0. So the question is, can I factor this equation? One telltale sign if a resulting quadratic equation is factorable or not is to look at the options that you have. If you have rational alternatives, whole numbers, or fractions as your options, then you know for a certainty that you can factor it. But if you have imaginary numbers or radicals, then you know that it's not factorable. Then you have to use the quadratic formula or completing the square. In this case, our options are all rational, so that shows that this is factorable, okay? So we're going to use the x game again, as I indicated earlier in number 7. Hopefully, well, we know it's going to work here. Number 7, it fell apart. It didn't really work, but this should be factorable. Okay, AC goes on top. A is 1. C is -3. And then B is -2. Okay, so what two numbers multiply to give you -3 and add to give you -2? The only two numbers I can multiply to get 3 is 1 and 3. Okay, now you have to be really careful to make sure that the signs work. Okay, I need to orient my signs in such a way that the product is negative and the sum is -2 also. Okay, so if the sum is negative, that means the bigger one has to be negative. Okay, so does that work? Yeah, absolutely it works. So what I'm going to do is I'm going to write this as x, take the first factor, plus 1, and then the second one is -3, equals 0. The reason why I can jump from the x game to the factored state is because a is equal to 1. If a were not 1, if it were some other number, then I have to factor by grouping, okay? All right, so that's a factored state. So does this mean that 1 and -3 are our answers? Does that mean that our answer is option number 3, 1 and -3? The answer is no. Remember I indicated to you earlier that you have to set the factors equal to 0 first before determining what the zeros are. Set them equal to 0 and solve, okay? So there's still one more step that involves the zero product property, set both to 0 and solve. Okay, so you subtract 1 from both sides. So you end up with the opposite. -1, that's the first 0. Here you add 3 to both sides. X equals 3, that's the next 0. Okay, so our zeros are -1 and 3. All right, these are our zeros. So let's go back to our option alternatives and see what our answer is. -1 and 3. Option number 1 is the answer for number 9. Okay, let's take a look at number 10, the last in this review series. It says when 2x minus 3 quantity squared is subtracted from 5x squared, the result is... Now, one caution you want to keep in mind is anytime you're subtracting expressions, always use parentheses and do not forget to distribute that negative sign. Okay? That's a big mistake a lot of students make. That parenthesis is a reminder. It reminds you to do the distribution process. Okay? So 2x squared is subtracted from 5x squared, so it's written in reverse. You have 5x squared operation, subtract, is minus quantity 2x minus 3 squared. All right, so let's go ahead and expand 2x minus 3. This is the same thing as 5x squared minus 2x minus 3 times 2x minus 3. Okay? Okay, so what we're going to do here is distribute these two polynomials across each other. Now, one method that students like using is the box method. It helps you stay organized and minimizes the chances of making mistakes. So let me show you that method real quick. It's pretty cool. So I'm going to use the box method to expand 2x minus 3 times 2x minus 3. Okay, so I'm going to put 2x minus 3 here, and then 2x and then minus 3 here. This is a multiplication grid, okay? So 2x times 2x is 4x squared. 2x times negative 3, number times number, negative 6x. And then 2x times negative 3, negative 6x. Negative 3 times negative 3 is positive 9. Okay, the nice thing about this is it keeps everything organized so you don't get things confused. All right, so you have 5x squared minus, now remember I told you earlier, do not forget to use the parentheses when you're subtracting expressions. If you drop the parentheses, you get the problem wrong. Okay, so above the parentheses, now this is how you write the answer. 4x squared, the terms on the diagonals are like terms, so I can combine these two. Okay, what is negative 6x minus 6x? If you combine those two, you get negative 12x. Okay, so the two middle terms combine to give you negative 12x, and the last term is plus 9. Okay, if you don't like using this box, if you want to just distribute, that's perfectly fine. Okay, I'm just trying to show you a nice little way of simplifying the process and reducing the chances of making mistakes. Okay, let's finish this off. Now, what was the caution that I gave earlier? The second part of the caution I gave earlier. Don't forget to distribute. You see this minus right here? Think as though there's a minus 1. And that is getting distributed to every single term. What does that do? It causes the signs of each term to flip. Okay, so this is positive, it becomes negative 4x squared. This is negative 12x, it becomes plus 12x. And this positive 9 becomes what? Negative 9. All right, so now let's simplify, combine like terms. The only two like terms here are the x squares. So 5x squared minus 4x squared is just x squared, or 1x squared, plus 12x minus 9. Okay, so this is the result. Our answer is option number 3. That's our final result. Thanks so much for taking the time to watch this presentation. I appreciate it. If you found the contents of this tutorial helpful to you, do give us a thumbs up. Your positive feedback is very valuable to us. And do not forget to subscribe for updates to the remainder of this review installment. If you have any questions about the contents of this presentation or any math concepts on the Regents exam in general, just place your question in the comment section below and we'll be glad to assist you at our earliest convenience. More clips can be found on mathgotserved.com under test prep. Thanks again for watching and have a